Hi all, I am K. Surya working as assistant professor in the Department of ECE at SNS College of Technology. In this video, let us see about columnar transposition technique. So this is one type of transposition cipher which represents the plain text in the matrix form. The writing the plain text out in the rows and reading the ciphertext in the column at a time is known as columnar transposition. So here the message is structured as a two-dimensional array. The length of the message determines how many rows and columns will be needed. If the message is 30 characters long, for example, so consider the spaces also, there is a 50% chance that there will be 15 rows and 2 columns, 10 rows, 3 columns, or 5 rows, or 6 rows, etc. You have to keep in mind that we have to append a dummy letter at the end in order to uh, fix the matrix completely. So we'll see what is the encryption technique. So first here we'll be writing the plain text in the rows that are defined in advance with the key determining the length. So the number of letters in the key represents the length of the rows in the matrix. The order in which the plain text columns are transposed can be determined using the key. So let us see an example for this so that we can understand better. When the ciphertext is created by reading the transposed plaintext in a column by column manner. For decryption, we'll be using the same key which we used for encryption, and the ciphertext is first transposed by columns. The plaintext can be retrieved by reading the transposed ciphertext row by row. So here again you have two types of columnar transposition. One is a singular and the next one is double or triple like that. So when we do the encryption once, it is known as singular columnar transposition. And when you use the encryption more than once, then we can say it is a multiple columnar transposition. So when you go for multiple keys, the encryption will be very effective and it will be difficult for the third party to find out the plain text using the attacks. So some of the key features of this columnar transposition is that it requires rearranging the plain text into columns before encryption. Since the key is symmetric, it can be used for both encryption and decryption. And this columnar transposition cipher allows for a variable key size. The key comprises of a permutation of the integers 1 to n, where n is the plain text length. Cryptanalysis can break a columnar transposition cipher, particularly when the plain text has repetitive patterns or it is short. So now let us see an example here. So consider the plain text. The tomato is a plant in the nightshade family. So you'll be creating a matrix. So here let us take the key as tomato. So TOMATOA. So first we'll be numbering this key based on the alphabet. Since A is the first alphabet, you'll be representing it as 1. And the next alphabet here, according to the alphabetical order, is M, which is mentioned as 2. Then O is 3. Since we have two O's here, the first O is mentioned as 3 and the second O is mentioned as 4. Then again you have two T's. So the first T will be 5 and the second T will be 6. So this is the order of the key. Okay, so next we'll be writing the plain text here. So we are creating a 6 column matrix here. So we are having 8 rows here. Uh, so you're writing the plain text as the tomato is a plant in the nightshade family. We are writing in the row and then you have 4 spaces blank. So in those places at the last you are putting as XXXX. Okay. After that, in order to find out the ciphertext, we'll be considering the numbering which we have done for the key. So since the A is marked as 1, first we'll be reading that column. So it is TINESAX. So first ciphertext, the first will be TINESAX. Then the second one is M, where that column is EOAHTFX. Then the third one is HTLTHEY. Fourth one is MAIIMIX. Fifth one is TAPNGDL. And the sixth one is OSTNHMX. So this will be your ciphertext. So in order to decrypt this, again, what you can do is you will be writing this ciphertext in the column manner, and then you'll be using the same key and you can decrypt. So the first you'll be reading it in the form of rows. So we'll be getting the plain text again. This is how the columnar transposition is working. So again, since this is one time, so if you want, you can use this ciphertext again. You can fill this ciphertext in a row-wise manner inside the matrix. You can use the same key or you can use a different key, and again you can find out a new ciphertext. So which will be in a more encrypted form, and it provides better security. Some of the use cases are it's used for applications like data protection, military communication, and espionage. And it works particularly well for situations when the plain text includes long repetitive patterns like binary data or DNA sequences. In order to increase the security of the encrypted data, columnar transposition ciphers can also be combined with other encryption techniques like substitution ciphers. Some of the advantages are it's a basic level of safety by rearranging the order of characters in the given plain text. So the property makes it hard to unauthorized users for deciphering without the knowledge of the key, and it is very easy to implement because it needs minimum resources. And it supports many key lengths, means it allows the users to customize the level of security as per their specific needs. And unlike the other substitution techniques, this is not preserve the frequency of the characters. So in order that it cannot be analyzed, or the third party cannot find out the plain text using the frequency analysis attacks. Some of the disadvantages here are it provides only basic security, and it is vulnerable to brute force attacks, especially in limited or weakly selected key spaces. And a known plaintext attack can compromise cipher security by revealing the details of the encryption key. And despite the suitability for basic encryption needs, the cipher cannot withstand determined adversaries or advanced cryptanalysis techniques. Furthermore, its performance decreases with large explicit text. Uh, so hope you understood what is columnar transposition and how to perform it. Let us take up some assessment questions. Columnar cipher falls under the category of the options are monoalphabetic cipher, polyalphabetic cipher, transposition cipher, and additive cipher. Yes, the answer is transposition cipher. Next one is which of the following cipher is formed by applying columnar transposition cipher twice? The options are rail fence cipher, root cipher, double transposition cipher, and one-time pad. So here the answer is double transposition cipher. Thank you for watching this video.